Hello, in this video I'm going to go through another Roslyn example, and this example is going to involve a custom Visual Studio QuickInfo source. Let me first show you what QuickInfo is. Okay, so here I have Visual Studio open, and here if I hover over the type of the customer variable, I get this tooltip, and this tells me that this is a class and that it lives in the console app1 namespace, right? Here, if I hover over this method name, it shows the signature of this method, and here I can even click on the method, and this will take me to the method. So in Visual Studio, this is called QuickInfo, and this is part of IntelliSense in Visual Studio. Now let me show you a demonstration of the custom QuickInfo that we are going to build. So here, I have an abstract class called shape, right? This class has two nested classes, square and circle. Both of these classes are sealed and they inherit from shape. So square and circle are two types of shapes, right? And because here we have a private constructor of shape, only classes nested inside shape can inherit from shape, right? This guarantees that shape has only two subclasses, square and circle, right? I call this shape class a sum type, and basically a sum type is a type of which value is one of a predefined set of subtypes, right? So I talk about sum types in one of my articles, and I'm going to provide a link to that article in the description box. Okay. So here, if I hover over this shape class, I'm getting this tooltip, and the first part of this tooltip is from the built-in QuickInfo of Visual Studio, right? However, the second part is the result of a custom QuickInfo source that I developed. This tells me that this is a sum type and it has two cases, square and circle. Okay, so let's get started. So here I have an empty Visual Studio solution, and I'm going to add my first project, which is a VSIX project. Okay, now I'm going to add a class library that will contain the implementation of the QuickInfo source. Okay, so in the VSIX project, I'm going to create a QuickInfo source provider. Let me show you. So I have pasted some code I prepared before. So this class implements the IAsync QuickInfo source provider interface, and this interface is part of the Visual Studio Extensibility API, and it has nothing to do with Roslyn. This interface has a single method called try_create_QuickInfoSource. This method will be called by Visual Studio. We are given a text buffer, and you can think of this text buffer as a Visual Studio document like this one, right? And here we are expected to return an object that implements the IAsync QuickInfoSource interface. And this basically will be an object that will provide QuickInfo for this document, right? And Visual Studio will discover this class using MEF, which is Managed Extensibility Framework, right? And I talked about this in previous videos. This is the relevant attribute, the export attribute, and this is how we tell the Managed Extensibility Framework that this class is a QuickInfo source provider. This content type attribute, it allows us to limit the usage of this provider to C# documents, right? Okay. Another step we must do is to add an asset. Let me show you. So I'm going to open this source.extension.vsix manifest file. I'm going to assets here. I'm going to add a new asset of type MEF component. The source is a project in the current solution, which is the VSIX project. Okay. And as I explained in previous videos, this instructs the Managed Extensibility Framework to look into this project for MEF components, right? Okay, so now I need to implement this class And I'm going to do that in this project. Okay, I need to add some new Git packages. I'm going to open this project file. Okay, and here I have pasted these references. So these 3 references are related to Visual Studio Extensibility, and these 2 are related to Roslyn. Okay. So this interface has 2 methods. The dispose method, which will be called after Visual Studio is done with the QuickInfo source, and then this method, which is the get QuickInfo item async method. So this method returns a task, which means that this method can complete asynchronously, right? So in this method we are given a session, a QuickInfo session, and then a cancellation token, and we are expected to return a QuickInfo item, right? So here we are allowed to return null if we don't want to display a QuickInfo tooltip, or we can return an object of type QuickInfo item. So let me show you the simplest implementation. So I will explain the first parameter later, but here I'm creating a simple QuickInfo source that always displays this message as a tooltip. Let me run the extension. Okay, so here I have an error. I simply need to reference the class library from the VSIX project. Okay. So I'm running again. Okay. So now if I hover over this variable, for example, I'm getting the default QuickInfo here, but then also I'm getting this message, which is from our custom QuickInfo source, right? Okay. So let's talk now about this session. One interesting thing I can access using this session is the trigger point. Let me show you. Okay. So here in the provider class, when I'm asked to provide a QuickInfo source, I'm injecting the text buffer into my QuickInfo source object, right? I'm storing this dependency in this field, and then I'm using it here. Okay, so here I'm using the session parameter to get the trigger point. So basically the trigger point is the location in the document from where QuickInfo was requested, right? For example, if I hover the mouse here, then this is the trigger point, right? Okay, so here I'm accessing a property called current snapshot in the text buffer, right? And snapshots are a way for Visual Studio to provide multiple versions of a single document. So basically each text buffer has multiple versions. Whenever we edit the buffer, we get a new version. And here I'm getting the trigger point based on the current snapshot, right? Now for me this doesn't make a lot of sense, because why do we need to specify a specific snapshot? Shouldn't the session tell us which snapshot triggered QuickInfo? QuickInfo is triggered on a specific version of the document, right? So if I hover the mouse here, I'm triggering QuickInfo in this version of the document, right? Okay. So here the trigger point is of type snapshot point, and it's nullable, meaning that it can be null. And again, I don't know the reason for that. Okay. So here I'm accessing the position of the trigger point, and this is basically the character offset of the location from the beginning of the document, right? Okay. And to be clear, all what I did so far has nothing to do with Roslyn. This is all Visual Studio Extensibility. Okay. So now comes the part where we use Roslyn. Okay. So this method, the getOpenDocumentInCurrentContext with changes method, this is an extension method. And this method is defined in the Microsoft.CodeAnalysis.Editor features.txt new get package. And this extension method, it allows us to get a Roslyn document from a snapshot, right? So this iText snapshot interface, this is from the Visual Studio SDK, right? But this document object, this is from Roslyn. So basically you can think of this extension method as some kind of bridge between these two things, right? Okay, so now I have this Roslyn document and I have a position, and now this allows me to get the node, the syntax node in the document at this position, right? Okay, let me do that. Okay, so here I'm using the find node method on the root node of the document to find the node that is on this position, right? And this method takes a text span because you can use it to find a node that contains a span, not just a position. But we can think of a position as a span of length 0, right? Okay, so I don't want to continue working without tests. So now I'm going to start writing tests. However, I don't want to test using this method because it's hard for me in the test to provide a QuickInfo session. Instead, I'm going to create a method that contains most of the logic, and that method would be convenient to test. Let me show you. Okay, so let me explain what I did. So let me start by explaining why I need to return a span from this method, right? So if I hover over any identifier, like this result here, after this tooltip appeared, the tooltip will not go away as long as I remain over this identifier, right? Like even if I move within this identifier, the tooltip remains, right? But if I move outside it, the tooltip disappears, right? So this is the concept of applicable to span here, right? So when we return this QuickInfo item object, we tell the consumer, which is Visual Studio in our case, the span that this result is associated with, and this will let Visual Studio know when to make this tooltip disappear, right? Basically, we will give it the span of this identifier, for example. So this explains why here I need to return a span from this calculate QuickInfo method. So here in this method, I'm passing a document, which is a Roslyn object, a position, which is agnostic really to any technology, and then a cancellation token, and then I'm returning the message that should be displayed and the corresponding span, right? And here I'm using a nullable tuple to give this method a chance to return null, indicating that we should not display any QuickInfo, right? Okay. Now here, I'm calling this method. If there's no result, I'm returning null. Otherwise, I'm creating a new QuickInfo item object. I'm using the return span to create what is called a tracking span. And this tracking span concept is a Visual Studio extensibility concept. And here when I create this tracking span, I need to specify a span tracking mode. This is outside of the scope of this video, but this has to do with what should happen to the span when the document or the text buffer is edited, and this edit is close to the edges of the span. Okay, so now here I can write my tests against this method, and this will be very convenient for me because I know how to create a document object, right? Okay, So for now I'm going to return null and start writing tests. So let me rename this file because it's called class1.cs. Okay, so I'm going to create a testing project. Okay, so I'm going to paste some tests that I prepared before. Okay, so I have some errors. I need to add a reference to the project and then a reference to the Roslyn NuGet package. Okay, I need to import the namespace. Okay, so here I have a basic test. In this test I have a sum type, it's called shape. It has only one subtype, square. It has a private constructor, it's abstract, and the subtype inherits from shape, right? So this is a valid sum type, and here in the test I have a variable of type shape and the variable name is also shape. Here I use an asterisk to denote the position where QuickInfo was requested. It's like where the user positioned the mouse to obtain QuickInfo. And here I use these bars to indicate the span that I expect to be associated with the QuickInfo. Okay, so here I expect QuickInfo to display this message, right? Some type cases and then square here. Okay, so let me show you the run test method. I'm not going to go into details, but I want to show you that I'm using this calculate QuickInfo method, which is the method we created specifically for tests, right? Okay. I have other tests here. For example, I want to make sure that if the sum type is not abstract, it's not considered a sum type, and therefore no QuickInfo should be displayed, right? And here I'm using null to denote that I don't expect there to be QuickInfo. Same thing here. I'm testing that if the case class is generic, then shape shouldn't be considered a sum type. Okay. Here also I test the case where there's a public constructor of the sum type. If there's a public constructor, which is implicit in this case, this type is not considered a sum type. Okay. Here I test the case where the case class does not inherit from shape, which means that shape is not a sum type. Okay. Here I test the scenario where we have two cases, square and circle, and the expected message should have the two cases. Okay, so let me run the tests now. We expect them all to fail. Okay, so actually 4 tests passed, and this is because currently we always return null, and these tests expect the return to be null, right? That is, they expect there not to be QuickInfo. Once I start working, these tests will fail, and this is very important. We should see these tests fail before we make them pass again. Okay, so let's go to this class now and start implementing. So the first thing I'm going to do is make sure this node represents an identifier. Let me show you. Okay, now at this point we are sure that the node is an identifier, which for example could represent a variable type, right? Okay, now I need to make sure that this identifier represents a symbol, which is the sum type class in our example, right? To do that I need to get the semantic model first. Okay, so at this point I'm guaranteed that the identifier refers to a symbol, a name type symbol in specific, but now I need to make sure that this symbol is a class. Okay, so now we know it's a class. I'm going to get all the nested classes of this class and consider them cases for the sum type. Okay, now I'm going to get the names of these classes and calculate the QuickInfo message. So now I need to return the message and the QuickInfo span, and the QuickInfo span will be the span of this identifier, right? Okay, so let me run the tests. So these two tests here failed before, and these were passing, right? So let me run them all now. So now it's the other way around. These two are passing now, and these are failing. We saw these two fail before, and now they pass, and that's great, right? Now we are seeing these failing, and now we can fix the system under test to make them pass. Okay, so let's go through them one by one. This test is about making sure the sum type class is abstract, right? Okay, so here I will check for that. If it's not abstract, I'm going to return null. Okay, let's run it. Okay, good. This test requires the case types to inherit the sum type, so we need to check for that here. So here I'm making sure that the case classes we select have the sum type as their base type, right? Okay. Okay, so the test is still failing, and here the error message says unexpectedly a QuickInfo message was returned, and the QuickInfo message was sum type cases, and then there are no cases. So what I did here is correct in that it didn't consider this type a case type. However, this didn't prevent a message from being returned, right? And this is simply because here we are not checking to see the count of the case types, right? Okay, so here I'm checking to make sure that we have some case types, right? Okay, so let me run it again. Okay, it passes. So this next test, it requires case types to not be generic, right? So here I'm going to do more filtering and require the case type not to be generic. Let me run the test, and it passes. So this next test, it requires the sum type constructor to be private, right? So let's test for that. So here I'm making sure that the sum type has only one constructor, and I'm also checking that that constructor is private, right? Let's run the test, and it passes. Okay, so let's run all tests now. Okay, and they pass. Great. So in summary, we can use Roslyn when we are writing Visual Studio extensions, and if we have a text buffer that has a corresponding Roslyn document, we can use this extension method here to obtain the corresponding document, and from that point on, we can use Roslyn to obtain information about the syntax in that document and the semantics of the code in that document. And after we do that, we can use the obtained information to return data in the structure that Visual Studio extensibility requires, right? Like this QuickInfo item class. Okay. I hope that you found this video useful, both for Visual Studio extensibility and Roslyn, and thank you for watching.